السلام عليكم، يعطيكم العافية. في المحاضرة الماضية خلصنا حل هذا السؤال. بضل عندنا هيك سؤال واحد في بارت الفلويد واللي هو هذا السؤال. مش متأكد إذا هذا السؤال عندكم منزل على السلايد أو لا، بس anyway هي صار معكم. خلينا نشوف هذا السؤال إيش بده. In this question, water at 40 degree Fahrenheit, and please be careful, the units here is not SI unit, so who knows, maybe I will bring questions like this. Okay, so this is very good practice. So water at 40 degree Fahrenheit, and here is the property for water: density and viscosity. Okay, those are the property. Is flowing through 0.12 inch. This is diameter, and here is the diameter. Okay, and here is the conversion. Okay, here is the diameter, and this is converted to foot. Diameter, and its length is 30 foot long, horizontal. This is horizontal pipe, constant diameter, steadily. This is steady state condition. And this is the averaged, be careful here, it's written average velocity 3 foot per second as shown in the attached figure. Determine the head loss, so we need to find HL and pressure drop delta V, okay, and the pumping power W dot, which is equal to volumetric flow rate multiplied by delta V. Okay, now let's see how we can solve this question. So first of all, we have this pipe. Okay, this pipe has constant diameter, which is 0.12 inch or 0.01 foot. 0.01 foot, and its length is 30 foot. Okay. So, and the property is given. So we need first of all to find. We need to find head loss. So this is part A, head loss. You know from the slides, okay, that the head loss, this is the equation for head loss. So let me go back. So head loss equal to friction factor multiplied by L divided by B multiplied by V squared over 2G. And if you notice that in the statement of the question, here we have certain conversion. We'll benefit from them. I will show you when we'll benefit from them. Okay? Okay. And here, how many unknowns we have? HL is unknown. Okay, HL is unknown. Also, friction factor or Darcy friction factor is unknown. Average velocity given, length given, diameter given, and G in the bridge unit 32.2 foot per second square. So how to find friction factor? We know that the flow may be laminar, may be turbulent, so we need to check. So how to check? We need to calculate, correct? We need to calculate Reynolds number, which is equal to rho V multiplied by diameter divided by viscosity. So yeah, 62.42 multiplied by velocity, which is equal to 3, multiplied by diameter, which is 0.011. I'll use foot instead of inch because the density and viscosity given in foot. So viscosity equal 1.038 multiplied by 10 to the minus 3. And the Reynolds number would equal to, so the Reynolds number will equal to 1804.04, and this is less than 2000. So from here we can say that the flow is laminar. Once it is laminar, then we can calculate friction, or there's friction factor, which is equal to 64 over Reynolds number, and that's gives us, so let me write it again, 1804, so 64 divided by this answer is 0.035. Okay, now we'll go back to the velocity equation, so, or headless equation, sorry. So 0.0355 multiplied by the length, which is 30, okay, divided by diameter, which is 0.01, multiplied by velocity, average velocity squared, divided by 2, multiplied by gravity acceleration, which is 32.2. And the answer is 14.9 volts. This is the part A. Now part B, we need to calculate delta B. So delta B equal rho multiplied by G multiplied by HL, okay, and this is equal to 2.42 multiplied by 32.2 multiplied by H, which is equal to 14.9, and the answer is 9947.8, but the unit is pound mass. You can check the unit, foot per second squared. Now we'll benefit from conversion. So if we go back to the question statement, we'll find this conversion here, this one. So in order to convert pound mass foot per second to pound force, then we need to divide by 32. So the answer here, multiplied by 1 over 32.2, and the answer is 929 pound force per foot squared. Okay. Now part C, we need to find out the W, or pump pumping power, which is equal to volumetric flow rate multiplied by delta B. So volumetric flow rate, which is equal to V averaged multiplied by cross-sectional area multiplied by delta B. And this is equal to 3 multiplied by multiplied by diameter, which is 0.41 squared divided by 4 multiplied by pressure, which is equal to 9 to 9. And the answer is and the answer is 0.218 pound force foot per. Now here we come to another derivation. So if we go back to the question statement, this is the second conversion, pound force foot per second to watt. So we need to divide by 0.737. So this is multiplied by 1 over 0.737, which is equal almost to 0.3 watt. This is the duct for pumping pump. So that's it for the fluid part. See you in the second part, which is thermodynamic part. Bye.